Hello friends. So in this tutorial, I am going to discuss how to take appropriate angular and linear measurements for your simulation inside the atoms by using function builder or system elements. So why I recommend to use some system variable or system elements function builders, because we can get targeted output or desired output as per our requirement. Although if in our post processing you can get outputs, but sometimes it is possible that those are not enough and not sufficient actually, and we need system variables for that. So we will start with the tutorial and I will explain how those are very useful. And normally in industrial practice, we prefer using system variables for any kind of measurements. So here we will see angular measurement and linear measurement. There are different measurements, but we will prefer commonly utilize angular and linear. So here I have built three bodies. This is a crank, this is a simple connecting rod, and this is a slider. So this is a slider crank mechanism which where it will slide and it will rotate and this will also rotate. So let me build connections first. So I will create a revolute joint for crank and ground at this center location. Then again a revolute joint between rod and this crank at this center point. Third revolute joint between slider and this rod, right click, okay, at this point. And last one is a translation joint for slider and ground. Here I will choose slider CM and this direction. Let's say this is a Y. Okay. So these are the joints. So I will view in 3D. This is a simple cylinder. You can build from this cylinder, and these two are links. So simple geometry it is. And let me apply one motion to this joint. So here impose motion, you can directly apply from here as well, no issue. So rotation Z, so I will give velocity, I want to give, let's say, 4 revolutions in 1 second. So let's say 4 into 360 d for degree. So in 1 second it will complete 4 rotation, 360 degrees for one rotation. So this is my angular velocity for this rotation, and it will show the direction here, this arrow. It depends on where the joint axis is oriented. Let's say here, first apply, okay, let's say joint, you will see, let me zoom it, here marker. So blue color is for Z marker, and Z marker is the axis of rotation, and it is pointing towards screen or viewer, and it will use the thumb rule, right hand thumb rule, and it will decide the direction. Let's say if Z is oriented in opposite direction, it would have been in opposite direction, this clockwise direction. So remember that. But also you can see the from the arrow direction, no problem. So first I will simulate it. Step is a 1 e minus 3 and end time is a 1 second. We'll simulate it. Okay, it is complete, and observe the animation whether it is completing 4 revolutions, 2, 3 and 4. Okay. So it has now completed the 4 revolution for verification. So let us assume that we want to measure angle of rotation of this crank and the linear displacement of the piston. So we will use system variables or using function builder for that. So although in post processor you will easily find the those values from this result set, let's say crank, and let's say I want to go theta, or let's say psi. This way you will get, let's say, angular velocity about Z, so it is degree per second 41440, that is a 360 into 4 degree per second. So you can measure, but let's say when mechanism has lots of bodies, complicated mechanism, those kind of ready-made available or inbuilt inside the post processor won't be sufficient. So better way to create the variable. So here we will use function builder to measure the angular displacement, that is angle of crank, and linear displacement or distance of the piston. So let us start with our first variable. So here we will measure angle of rotation of this crank, and this crank is rotating about this point. So let's say joint. So we'll see what are the markers associated with the joint. So if you right click on the joint, you will get the info. So here you can see I marker is on crank, which is marker number 17, and J marker which is on a ground, because second body is a ground for that joint. First body is crank. So marker 17 is associated with crank. Marker 18 is associated with ground. So obviously ground marker will be the stationary, and marker 17 which is connected or associated with crank is a floating marker or moving marker. So we want to measure angle of this marker. So let us create one variable. So go to the elements, system elements. Here is the option of this x, create a state variable defined by algebraic equation. So measurement is my name of the model, and for variable, let's say give some name. I want to give the name of, let's say, crank angle. So here f of time. So here you can use runtime expression f of time, that is a function. So if you click on here function builder, it will go to the function builder. First erase this 0, default 0, and here you will find lot of functions. So if you click on all functions, it will show the all the functions. Let's say we go to displacements. So we want, let's say, display distance along x, distance along y, distance along z. Distance in magnitude, let's say angle about x, angle about y, angle about z. So I will close this first, and let us see. So for this marker 17 and 18, so crank marker 17, you can see x is this one of the marker 17. It is highlighted. If I choose different, it will highlight that marker. So marker 17 is highlighted. So blue is a z-axis, red is x, this green is a y-axis. And let's see the ground marker, which is a fixed one, which is associated with that joint. So same marker you can see, you will find this cross lines when the marker is fixed. So x is this, y is z, sorry, y is this, and z is the, now here z is the rotation axis. So we want angle about the z axis of the marker 8. So don't consider global coordinate system, choose or prefer local coordinate. Let's say if ground marker is not there in some bodies, it is not, let's say marker is not available, then you can create one marker which is connected to ground, and you can take a this ground marker as a reference marker. So remember, your reference marker should be the ground marker. So go to the function builder. So here I want angle of the link about z axis of this um, marker 18. So go to the this displacement. I will choose angle about z because this is the axis of rotation. If it is different, you can choose x, y, z. And here in bottom, it will show az to marker from marker. So better way, you click on assist. So to marker, so marker 17 is my measurement marker or my moving marker, and from marker is my this marker 18. So I will just control C and here I will paste it, Control V. Or you can simply write here marker 17, or if you want to right click, guess or pick or browse. So there are different options you can choose. So simply I am just simple clicking here, and I am copying this text and pasting here. So I will click OK. So two marker is my marker for which I want to do the measurement, and marker 18 is my reference marker. And you have to careful about axis X, Y, Z, which axis. You have to look for local axis, not a global axis. Remember that. So now my expression is ready. So A is for angle, Z is for angle about Z. So AZ. So verify function syntax is correct. Now you can click OK and OK and run it. Okay, once again run it and we'll see the value of that variable. So let me fit it to the screen and go to the post processor once again. And here you will see result set from last run. There is one variable called crank angle is now appearing here, and component is a Q, that was our measurement, add curve. So you will see it is from 0 to last value is 20.13. So what was the total angle of rotation? That was the 4 into 360. But here it is not a 4 into 360. It is something around 25 into 137 because it is now in radian. Let's say if I open the calculator. So one rotation is the 360 degree. That is a 2 pi. So 2 into 3.14 into 4. So 25.12. So this is showing me the total angle of rotation. This is in radian. Let's say if I want to in degree, there are two ways. Let's see if I go to the math and choose this graph, it will appear here. Y expression is the angle expression. Let's see if I multiply to convert into radian to degree, you have to multiply by 180 and divided by let's say 3.14. And if you click apply, so it will show you in degree. So here 1440, that is correct. But I won't recommend this. So let it be the original, and there is different way of doing. Let's say you can apply the unit from here also, it is angle and apply, but this is wrong. By default it is showing degree, but it is not in degree, it is in radian. And now we'll go to the radian, sorry, how to get in the degree. So here in model tree, go to the elements, and here will be the system elements. So from here we have created system elements. So crank angle is there. So just here you can use word called RTOD into this expression. So R means radian to degree. So basically it will multiply by 180 divided by 3.14. So this is a ready-made expression available, revolution, sorry, radian to degree. Now click OK. Once again run it. Now go to the post processor once again, and I will refresh the result because there is only one analysis. So now you can see it is now in degree. But we want like how many cycles it has completed. We don't want total angle. We want like 0, 360, then 0, 360, then 0, 360. This kind of measurement we want. Let's see how to do that. Let's say there is function called mod inside the Adams. It is very useful mod, and this is our expression for the measurement. And let's say what is our maximum value for the angle? It would be 360. And let's say if this expression reaches to 360 measurement, it will count from 0 again. So let's say initial angle is 0, it will start counting 0, 1, 2, 3 up to 360. Once this expression reaches the value of 360, again it will count from 0. So this is a syntax of mod. So verify, OK, This is a function called mod. Let's say if we go to the all functions, you will find here mod in yum. Is it there? Yum. Okay, here is a mod. So mod is x1, x2. This is a syntax. Let's say if I assist, no assistant available for this. So this is your first expression, and second expression is the what is the maximum value. So okay, and now okay. And if I run it again, let us see how the graph changes. Now initially it is straight line. Now if I refresh it, now you can see the what we want to get. So starting from 0, it reaches 360, then it will 0, 360, 0, 360. So this is the number of rotation we can count. One rotation, second, third, and fourth. So this is the use of mod. It is very useful function in the Adams. We will also see some example in upcoming tutorials about this. So this is the how do we want our actual result of the angular measurement. So this is why I prefer the variables. So now let's see for the linear measurement of this piston. So now we'll create one more variable. So go to the elements. Here I will call as the slider displacement. So you can rename lateral, so no problem. Go to the again function builder. First erase this 0 and now go to the displacement and let's say distance along x and y and z. So let us see first markers. So what is a joint? So joint 4. Let's go to the info of that joint. First clear all previous ones so that it won't create any confusion. Info. So marker 23 associated with slider and marker 24 associated with the ground. So 24 marker is the grounded marker. So this is our reference marker. So close it. Now see the ground and marker 24. Now you can see orientation of this marker. Z is along the vertical direction. So local Z is oriented along the global Y. So global axis, if you see, this is the Y and local, in local it is a Z. So we always use local here. So it should be distance Z. So assist it, to marker. So this is my marker 23 in a slider, which is my moving marker. From marker, that is my reference marker 24, and along marker, if you keep blank, it is okay. Also, you can keep marker 24. So I want to measure along 24 marker. So if even if you keep it is a blank, it is okay. So this is my expression, verify it. So dz, distance along z. Marker 23, so moving marker, my reference marker, and axis of that marker, reference marker. Axis of reference marker is a z, not a y. Y is a global, but if you see blue color, this is a z axis of that marker 24. So you have to check the component properly. We will also experiment with the if we change the axis. And what should be the piston displacement? It should be the equal to length of this crank, or crank is the, let's say how much is the crank length, marker 1, marker 2, it is 100, that means 100 into 2, it should be 200 mm. Okay, so run it simulation, again run it and go to the post processor. On right side I will plot. The next is the here slider displacement q, add curve. Now you can see 0 to 200 as expected, then 0 to 200 as it is completing total 4 cycle. It has no unit. You can add manually also. If you click here on this axis, you go to the label, you will find this no units. You can replace that, or go to the math, check this curve and for y unit it is a length. Let's say length and apply. So it will give length in millimeter. It is in negative. If you multiply with, let's say, -1, you will get in positive. Also, different way you can modify the variable here, slider displacement, simply -1 into dz, and run it again, so that you will get in positive value. Just it is doesn't create make difference, just for your better understanding. Positive is good. Okay, so let's say if I change the here, let's say dx or dy, what happens? Let's say because y is in global, that's why I kept it global, and basically it should return me the 0. Refresh it. So 0, because I am measuring about marker 24. This is my reference marker and it has z along the z. That's why this matters lot. And using variable you can't avoid number of mistakes, so it creates proper measurement. That's why we prefer creating such variables for our outputs or desired output, I would say. These are very helpful functions. You can refer the help menu, and if you search functions you will find lot of documentation on this. So this was for this lecture. You in comment section you can also tell about what kind of tutorial you want. I will try to create for that. And till now you can share such a tutorials among your friend circle, and you can subscribe, and thanks for watching this tutorial.